paper titled Statistical Distribution of Aerosol Optical Depth at UV Wavelength over a given savanna zone of West African region, Ilorin, Nigeria. And I want to, sorry. What is happening? I want to go by this outline: introduction, the statement of problem, research methodology, results and discussion, and finally the conclusion. The introduction. Aerosols are solid or liquid particles present in the atmosphere and move with the direction of the wind. They have their size ranging between 10 raised to the power -3 to 10 raised to the power 2 micrometer. They can influence the atmospheric chemistry and physics. They remain suspended in the air and move with the direction of the wind. We have two types of aerosol. We have the natural one and the anthropogenic aerosol. Example of the natural one are the dust, we have the sea salt, and the example of the anthropogenic, that is the man-made aerosol. They are gas, they are the gas coming from the exhaust, the gas coming from the industry. They are all example of anthropogenic aerosol. Then the extinction of the incoming solar radiation from reaching the Earth's surface by the aerosol is termed the word aerosol optical depth. So in this work, we want to know the variability of this aerosol optical depth in the UV region. And before that, let's talk about the statement of problem. The impact of aerosols on the UV radiation has received a lot of consideration in researches. So because of the health implication of the UV radiation on human and plants, this AOD, ultraviolet radiation coming from the sun. Several authors have studied the variability of aerosol, but in most of the articles, they study the variability in the infrared and the ultraviolet radiation. But in my own research work, we want to study the variability in the UV wavelength. The research methodology, the description of the study area. Ilorin, the location of the research is located at the University of Ilorin, Nigeria. It has a latitude of 8 degrees, 31 minutes north, and longitude 4 degrees, 34 minutes east in Kwara State, Nigeria. It has an altitude of 375 meters. The temperature in the average temperature is around 25 degrees Celsius, and in March, February, March, it is 35 degrees Celsius. Then the instrument used to measure the AOD, that is aerosol optical depth, is called sun photometer. That sun photometer, which is an automatic sun scanning filter radiometer, it allows the measurement of direct solar radiation at these various wavelengths: 340, 380, 500, 675, 875, 940, and 1020 nanometer. It was installed at the roof of Block 9 of the Faculty of Engineering, University of Ilorin. It is solar powered and the robotic pointed. The detail of the instrument, it can be found in Orbing, the 1998 article. And this is the picture of the sun photometer at University of Ilorin. Then how the data acquisition. 13 years data, that is from 2002 to 2014, of daily AOD at 340 nanometer was gotten from the archive of the Aeronet NASA station. The website is cited at the back of the slide. So a 13 years data was gotten from the archive. To 2004, and you can see it shows a monthly fluctuation from about 0.3 of sorry, it's because of the network. So because of the gap and want to study the variation of the AOD, we now introduce a smoother known as a center moving average. As you can see, that is the green curve. It shows that the AOD varies, increases from 0.7 to 0.1 in year 2005 to 2006, stable at around 0.73 in the year 2006 to 2007. Then it decreased about about the end of 2007, and then fall again until a minimum in the year 2009. Between 2010 and 2011, there is a gap there. That means we don't have the data of AOD for that particular year. But between 2012 and 2014, there is another fall of AOD. This may be possibly because of the campaign against bush body activities that is actually common in this study site. So because of those gaps that are common in the AeroNet data and the one shown in figure 2, we want to develop a technique to compensate for all the data gaps in the series. So now we now plot a box plot. What box plot does is that these whisker lines represent the maximum, while the other one represents the minimum. The box himself represents the spread of AOD in each of the year, while the black lines, the black line here represents the median score. It is the median score that we use to correct for all the fillings, all the data gap in the series. The AOD is plotted on the y-axis, while the month of the year on the x-axis. A represents January, 12 represents the December. At the same time, you can see how AOD varies monthly over the year. From the 9th of the month, that is September, AOD started to rise. As you can see, it rises up to December through January of the preceding year until a fall from March. There's another fall from March until July here, when everything is also stable. To further study the behavior of AOD, we now plotted the daily AOD for year 2005, 2007, 2008, and 2012. These years were chosen because they have a significant number of AOD data. The same thing, they follow the same trend. It rises from October up to December, then it goes like that to the preceding years, January, March, until then fall again, then stable at around the rainy period over the study area. So we move effort again to represent the average, daily average AOD for Ilorin from 13 years long data. It also follows the same trend. It started increasing from October up to December. Then it moved again to the January of the preceding year until a maximum in March, before it falls again till July, where it becomes stable. So we now fit the behavior of AOD, daily AOD throughout the year, and it gives an quadratic fit with R square value of 0.189, standard deviation of 0.1628, and the probability density is less than 0.1. This is, so we make effort again to fit the increasing parts of the behavior of AOD. The increasing part is between September and December, as you can see, and we now fit it with the days of the year. It gives a linear fit with R equals to 0.882 and standard deviation to be 0.128. Then the decreasing parts of the behavior, that is from March to May, we also fit that too. We have a linear fit with correlation coefficient of minus 0.RR2 and SD to be 0.128. Then the stable parts, we also fit the stable parts, that is the rainy period over the study area, that is between June and August. We found out that AOD with the days of the year gives a linear fit with R, a very fairly good correlation coefficient, that is R equals to 0.05, where standard deviation equals to 0.146. To study the frequency distribution of the AOD pattern, we now plot a histogram. Then the histogram shows that most of the AOD skewed around 0.5. And that shows that the majority, that at least 65% of the AOD falls between 0.5 and 1. And another 30% falls between 1 and 1.5, while only 1% falls above 2.0, and the remaining 2% falls less than 0.5. Then that leads us to now categorize AOD according to their size. For the study area, we classify any AOD less than 0.5 to be low. When it falls between 0.5 and 1, we clarify that to be medium. When it is between 1 and 1.5, we say it is high. When it is above 1.5, we call that of AOD to be very high. Now jump to the conclusion. A 13 years UV aerosol optical data have been used for this study, and the analysis shows the daily, monthly, seasonal, and annual variation. The statistical distribution shows that AOD skewed about 0.5 with a minimum value of 0.147 and maximum value of 1.859. The majority falls around 0.5 to 1 is about 67%, while that between 1 and 1.5 falls at around 30%. 1% fall above 1.5, while the remaining 2% fall below 0.5. The rate of AOD increases before rain period was higher than that of AOD increase after the raining period. So 4 classes of AOD were observed in the station, namely low, medium, high, and very high. Thank you for listening.
Thank you. Questions? If not, trecem mai departe.
Any question, please?
Okay, there's a question.
Right.
Can you hear me, please?
Okay, I'm hearing you.
Okay. Is there a difference between the variation notice using UV wavelength and your infrared or visible spectrum?
The only difference is just the size. They both follow the same trend, the same pattern.
Size?
Yes.
Or size of the difference?
The size of the dust makes the difference. Hello, Dr. Sarafa.
Yeah, I can hear you. Please go on.
The trend, the behavior of the two, whether infrared, visible, infrared, the ultraviolet, and the UV, behave the same way.
Okay,
Some
thank
of
you
the
very
side-
much. No more questions
Hello?
from me. I'm okay with the answer. Thank you.
Okay, all right.
Thank you.
You're welcome.
Următorul.
Dr. Bukunmi Makanjolo, you can start.
Good afternoon, ma. I want to share my screen now. Hello, please can you see my screen?
Not yet, yeah.
Make sure you open the slide. Make sure you open the slide first.
Yes, I've opened it. Can you see my screen now?
No.
Please, you are not sharing your slide.
Share screen
You are not
first
sharing your slide.
and open your slide.
Can you see it now, sir?
Yes, yes, yes.
Okay.
Okay.
Good afternoon,
Okay.
everyone.
Okay.
I'm Bukunmi Makanjolo from the Department of Home Economics and Food Science, University of Ilorin in Nigeria. I'll be presenting research. I'll be representing my colleagues, Dr. Adewumi and Dr. Samson. I'll be taking you through my slides, the flour composition and physicochemical properties of Amaheu, composited with the fattest soya bean, prepared with different inoculants. Here is my presentation outline. This is a typical picture of Amaheu. This is the commercial one, as you can see on slide 2. Now, Amaheu is a fermented beverage popular in Southern Africa. It is very popular in South Africa, Mozambique, Tanzania, Zambia, and some other Southern African countries. It is, as I said earlier, it is a fermented non-alcoholic beverage. It is consumed both traditionally and as a commercial drink, and it has diverse health benefits. It contains probiotic bacteria which can help the health of our colon to prevent colon cancer. Then it is gluten-free, it is dairy-free. It can be consumed either with sugar or with no sugar. It is high in carbohydrate content, but deficient in protein, which is why the protein energy malnutrition issue is attached to the consumption of Amaheu if it is dependent upon for survival. So this has led to many researches. Researchers have tried to improve the quality of Amaheu because of its deficient protein composition. So during previous study, we were able to see that. Before I go to previous study, I would like to explain how Amaheu is being produced. Amaheu is produced from maize, basically. Produced from maize flour, and this maize flour is just like if, I'm sorry to say this, many of my colleagues from Nigeria will know ogi. It's just produced like ogi, and it is produced from maize. The maize is used to produce a gruel, like a porridge, over 15 minutes on fire. Then it will be cooled to a degree, to a temperature of 40 degrees. Then this porridge will be inoculated with either maize malt or starter culture or yeast, just to ferment over 1 to 3 days. Then after then it can be consumed with or without sugar. So during previous studies, we have been meant to know that the fermentation of Amaheu, the inoculants which are used to inoculate it to cause the fermentation, they have a very great impact on the quality of Amayewu. As we all know, garbage in, garbage out. So that is why in 2010, Chelule used different kind of inoculums and found out that the organism responsible for the production of Amayewu is basically lactic acid bacteria and also yeast. More recently, Awubusui in 2019 helped to improve the protein quality of Amayewu by the addition of Bambara granite, which is an underutilized legume, and found out that the protein content of the Amayewu increased, and also the lysine content, which is a very important amino acid in the body. Also, generally, the shelf life, that is the period of time at which the Amayewu can stay, is between 1 to 4 days. Now, some Meshao et al. 2020 found out that if we add aloe vera to Amayewu, the shelf life can be extended to about 15 days. But there has not been any record of the addition of soya bean in Amayewu. And generally, we know that soya bean is very rich in protein and is also a low budget source of protein, which can help to improve the quality of different food material, especially cereal products, which are not rich in protein. It is easily available, and it is generally used, and that's great health benefit. So the addition of soybean to Amayewu can go a long way to help improve the protein quality, which can reduce, of course, protein energy malnutrition. Protein energy malnutrition is very popular in Africa generally. We see among small kids, we see small children, kwashiorkor, marasmus, inability to digest protein, low consumption of protein. So these are great issues which which solution should be found to. So the addition of soybean can help to improve the quality of Amayewu and to produce a new product. Hence, the objective of this study is to determine the flour composition and physicochemical properties of Amayewu composited with the various soybean prepared with different inoculum. Because if there is no inoculum, there will not be fermentation. There will not be desired fermentation. So specifically, we want to know the proximate and functional property of the flours used, which include maize, the fatted soya bean, and their composite flour. And we want to know the pH and TTA, then the sugar level of Amayewu produced from the fatted soya bean. The pH and TTA, we want to check to ensure that there was fermentation indeed. Then we want to check the color and the proximate composition to check if the addition of soya bean to Amayewu caused any change in color to the reference Amayewu being produced generally. So we want to check if the sensory acceptability of soya bean added Amayewu is acceptable by the consumer. These are the materials for the production, all sourced here in Nigeria, and dried, grounded to flour, ground to flour to produce Amayewu. As I explained earlier, this is the chart for the production of Amayewu. In this study, we are using 3 different inoculum. Then we are producing 4 samples, majorly the one without soybean addition, and 3 others with soybean addition, but inoculated with 3 different inoculum. As I said earlier, the maize is composited with soybean. That is 70% maize, 30% soybean. Then a gruel is produced for about 15 minutes at the 90 degrees Celsius. Then it is then cooled. Then our inoculum is added so that fermentation can occur. So when the sample reaches the pH between 3 to 4, which is acidic due to the production of lactic acid during the fermentation, we stop the fermentation by putting our samples in the fridge so that we stop fermentation, because if you not reduce the temperature, fermentation will still continue, which may lead to undesirable features of the product. Here is the result of the fermentation. You can see it look like milk, but it's not milk. But it look like milk, very white. You can add sugar, or you can take without sugar. It has a very slightly sour taste, which is enjoyed locally and industrially, especially in Southern Africa. So table 1 shows the proximate composition of maize and soybean flour. Generally, protein and carbohydrate are the major content of our flours. We have the maize flour, have the soybean flour, and the composited flour, the addition of 70% maize and 30% soybean. The addition of soybean to maize flour led to about a very great increase in the protein content, while in the protein content of the composited flour, about 20.7% in the protein in the composite flour. So table 2 shows the color of flour before the production of amayu. We can see from here that using our calorimeter, you can see the L value represent whiteness, the A value represent color region of red to green, and the B value represent the color region of yellow to blue. You can see here that the L value is very high, which means that our sample is white. Our flour sample is white. So we are looking forward to producing a product which is off-white, as I showed in the results. You can see that the product is off-white. Then the bulk density of the sample was also checked. The water holding capacity, the swelling index was also observed. The swelling index of flours shows how much water they can hold, like they can how fast they can rise if added to water. And that is why you can see maize flour having the highest swelling index because of the starch composition. Then the water holding capacity of the fattest soybean flour was higher than that of maize because of the polar amino acid which are present in soybean. So the addition of soybean to white maize led to 1.7 water holding capacity, increased the water holding capacity in the composited flour. So during the fermentation, the pH, as I said earlier, and the TTA was checked. This is the result for the pH. Generally, pH is meant to decrease with time of fermentation. So from this graph, you can see that from 6, the pH started dropping to about 4 point something in the sample without soybean addition. So this addition of soybean to this product led to about a little increase in the pH. So among the enriched samples now, the one inoculated with malted maize showed the least pH at the end of the fermentation, at the end of 48 hours. So you can see that the inoculums were different. With the result of the pH shows the difference in the inoculums. This is the titratable acidity of enriched amayu. During fermentation, acid will be produced, which will increase the TTA. So this result is corresponding with the pH value. That is, the pH decreased with the increase in fermentation time, and the TTA, which is the titratable acidity, increase with increase in fermentation period. So, as I said earlier, the sample inoculated with malted maize has the highest pH. Of course, yeah, it has the highest pH among the enriched sample. But the sample that was not enriched to soybean had the highest TTA generally. Here is the bricks, the composition of the sugar composition of the sample. It ranged between 25 and 27 for the unenriched sample. So the sample that was not added, soybean added, the soybean was not added. It has the least bricks sugar level. That means the addition of soybean to the sample led to a great increase in the pH. So this might be due to soluble solid which is present in the soybean too. So this is the color parameter for the freshly prepared and the sample were freeze dried because of analysis that will be carried over after the production of sample to keep the sample. It was freeze dried. Then you can see from here that the freeze dried sample has higher greater values for L value, which is whiteness, and all other parameters were significantly low, and the color change here was higher for that of freeze dry sample, as you can see, than the fresh samples. The samples did not show any significant difference due to because of the malt added. There was no difference because of the malt. There was no difference. So table 4 shows the proximate composition of amayu enriched with divided soybean flour. This is the control. The samples that was no soybean added. This is the control. This is the control. It shows the protein content is 8.39. So the addition of soybean helped increased the protein content to about average 26%, from 8 to 26. So this means that soybean addition is effective to improve the quality of amayu, especially in terms of protein. So you can see that the carbohydrate content has reduced, the ash content has increased, but the fat content has reduced too, which is positive. So, but generally, the sample that was inoculated with malted millet had the highest protein content, while the sample inoculated with malted maize had the least protein content. Table 5 now shows the sensory score of amayu enriched with divided soybean flour. Then you can see from this table that the samples were not significantly different from each other for all sensory parameters, but the overall acceptability, the sample inoculated with malted maize has the highest general acceptability, which shows that it is the most liked sample amongst the enriched sample or amongst all sample. This means that malted maize may be used and is the best inoculum if consumer acceptability or consumer preference is of interest. Conclusion: we can see that the addition of soybean at 30% level of inclusion led to about 210% protein increase, 141% ash increase, and 198 fiber increase. Soybean addition did not significantly affect the judgment of the panel members, which means soybean, or you add soybean or you do not add soybean, it doesn't change how the consumer of the product feel about the product. So that means soybean can be added to the product without any dislike by the consumer. So the chemical composition of the enriched samples were slightly different from each other because of the different inoculum used, because it's the only different within the samples which are enriched. We can see that the sample inoculated with malted millet had the highest Brix and protein value, while the sample inoculated with malted maize was most liked among the consumer. So I recommend
Dr. Bukunmi, your time is running out.
Okay. Generally, future studies are required to further determine the nutritional profile, digestibility, microbiology of the product. Thank you very much for listening, and we appreciate you for allowing us to participate in this conference for free. Thank you.
Thank you for your presentation. Do you have questions?
Thank you, ma'am. Any questions, please?
Please, I have one or two comments.
Dr. Akande Teslim, you can
Yes.
start.
Yes. I have 1 or 2 comments and at the same time some question.
Yes,
My first question is, all this your malted sorghum, malted maize,
yes, sir.
are you able to carry out some chemical or mineral constituent before it is being used as you have listed?
Before it is being used. No, sir.
Yes. Uh-huh.
We didn't carry
Then after that, because it may contain certain nutrients,
Yes.
compositions, and phytochemical that are counted for the increment in protein, and at the same time, the result you have given us. Another thing is, are you able to carry out in your final analysis?
Yes, sir.
Your final analysis. We expect you to carry out some health evaluation. Are you getting me now? Because you are talking about increment in pH, increment, that is the acidic level of your product. Are you getting me? So when you carry out the health evaluations, maybe using some experimental animal, are you getting me now? And we'll be able to get maybe we'll be able to get the medical effect of all of your product before it is being recommended. Are you getting me? Those are just my observation and questions.
Thank you very much, sir. I really appreciate it. Any other question?
I'm having audio problem.
Any other question?
Dr. Akande, I cannot hear you.
Those are just my recommendation and questions, my observations and questions. I mean,
Okay. Thank you.
So,
I hope
Maria,
you are hearing me.
I think we can proceed.
Can you hear me?
Yes,
John
let
will
us proceed.
Yeah, we can proceed because of time.
Professor Maria, let us proceed.
Dr. Teslim Adeyinka Akande, Dr. Elizabeth Oyetayo Oyakbalo, you can start.
Okay, thank you. Please, I'm having some problem.
Dr. Akade, open your PowerPoint.
Yes, I'm trying to do that.
Dr. Akande, presentation did
Yes,
not
I'm
open.
having some issue here, please.
Please tell us the problem.
I think it's the network problem. Let me reshare.
Screen
Can you see?
share.
Can you see?
We can't
Can you
see your
see?
slide. Yes,
Oh,
we
yes,
cannot.
yes.
We can see the screen now.
Yes. Can I start? Can you all see it now?
Yes,
Can
yes,
see it
yes.
clearly.
Please proceed.
Yes,
Okay.
please. Yes.
Uh, my name is Takade Teslim Adenka, and I'm presenting on behalf of Oyagbola Itayo Elizabeth. I want to present on phytochemical and pharmaceutical potential of Pseudodrella cocci and Viteria padoresis on some selected medical isolate. The widespread use of herbal remedy and health care preparation has been traced to the occurrence of natural products with medicinal property. Both Pseudodrella cocci and Viteria paradoxa are extensively used as medicinal plant value to cure specific ailments from ancient time in our indigenous medicine system. What I'm trying to say is that both plants, more especially the bark of the plant, has been used in various ways to cure various ailments and diseases traditionally, more especially in Africa and Asia. The objective of this research work is to carry out the antimicrobial activities of the bark of both the plant on certain important medical isolate, more especially the E. coli that causes a lot of gastrointestinal tract infection, the Staphylococcus aureus that causes a lot of skin infection, as well as the Escherichia fecalis and uh, uh, P. aeruginosa. The second objective is to determine the phytochemical content of the ethanolic plant extract of the bark and to determine the active compound in the ethanolic extract of the bark using GC-MC system. Now, the material method. The first thing is collection and identification of the plant. The plant bark were collected and were properly dried for 2 weeks, grounded into uniform powder, and it was soaked in different solvent, water, and 75% ethanol content. Although in the course of this research work, I mostly use 75% ethanol content because it has the ability to extract more than the aqueous extract. 1 gram of each of the extract was added to 10 ml of water and 10 ml of 75% alcohol to give a concentration of 1,000 milligram per ml, that which we start at the stock culture. Serial dilution of the culture was carried out as listed to obtain the stock culture. Now, the isolates used, that means the Pseudomonas aeruginosa, Staphylococcus aureus, Enterococcus fecalis, as well as the E. coli, were obtained from molecular biology department of Nigeria Institute of Medical Research in Lagos. Some of the material methodology, the method, the procedures carried out during the course of the research are qualitative determination of phytochemical, which will include the alkaloid, the flavulod, the tannol, the saponin, and the racemic sugar, as well as the volatile metabolite. Now, other procedures include the screening of the plant for antimicrobial activities, determination of the minimum inhibiting concentration of the extract, as well as the analysis, the metabolite analysis using gas chromatography, mass spectrometry, then as well as the identification and quantitative of the volatile metabolite. The result, the phytochemical analysis of the plant revealed that P. cocci contains acanol, flavonoid, tannin, anthraquinone, as well as the reducing compound, while the other plant extract, which is the V. paradoxa, contains alkaloid, flavonol, tannin, cardiac glycoside, as well as the sulfonin and the reducing sugar as well. The phytochemical compositions, where we are talking about the quantitative the quantitative measurement of all these phytochemicals found in all these extracts can be given in the table. You can see that the tannin is made of about 97.2 milligram per 100 gram of the plant in case of P. coccisis, and that of the phenol contains about 94.22 milligram per 100 gram of the isolate. Now, the solubility pattern of the organism to ethanol extract, because what we do is that we subjected the extract, the back extract, I mean the ethanolic extract of the plant, we subjected them to different organisms, and those organisms are listed like Staphylococcus aureus as listed before. So we try to determine the zone of inhibition by determining the pharmaceutical effect of all those ethanolic extract on the plant, and we can see that the higher the milligram of the extract of the higher the milligram of the extract, that means the higher the concentration of the extract, then the higher the zone of inhibition, which means the extract is very viable against all the microorganisms. The same thing happened to the other extract like the P. cocci. The P. cocci, you can see that E. coli is much more very susceptible. They are more susceptible to the extract than other organisms. Now, then we also carry out we also subject most of these multi-organism to the conventional antibiotics, and those are the conventional antibiotics which we normally use. Involve gentamicin, cotrimazole, ampiclox, tetracycline, augmentin, and what we have. So the reason why we subjected to conventional antibiotic is to try to compare them to our different extract. Now, this one you are seeing on the screen indicated the gram-negative dish, the gram-negative antibiotic dish that was subjected to different microorganisms, and while the other one indicated gram-positive antibiotic dish that was subjected to carry out their pharmaceutical effect on the microorganism in order to compare them. Now, the gas chromatography mass spectrometry analysis of both the extract we have done, and we are able to see that we have almost 12 compounds. That means we are talking about the motility compound, the metabolite, the chemical, the chemicals that are in the plant that make them to carry out these pharmaceutical or antibacterial activities. And those are which it contains a very high percentage of tetrazole, which is about 28%, as well as that of cyclohexane, which is about 21%, with a very low butyl dioxide, which is about 1.6%. Now, then the V. paradoxa also contains about 15 compound too, as listed on the screen. It has a very high, a very high amount of about 21.78% of hexadizine, as well as that of cyclohexane. Discussion. The presence of some phytochemical in the plant extract study is a function of their antimicrobial activity against the test pathogen, and they play important role in bioactivity of medicinal plant through different mechanisms. Antibacterial activities of the entire extract of the the extract increased with increasing concentration of the plant bark extract and was effective against Staphylococcus aureus, which was resistant to conventional tetracycline, augmentin, cycloserine. What I'm trying to say here is that since all those microorganisms was subjected to our antibiotics like augmentin, tetracycline, cycloserine, and what we have, we found that most of these isolates, we are talking about the microorganisms that are causing various diseases and various infections to us, got resistant with all these conventional antibiotics, but they are very sensitive to the two plant extract, which is an indication that the plant extract is very good for the curing of all those diseases. Also, the decrease observed in the antimicrobial activities of P. with increased concentration of the extract may suggest that the plant extract is a good source of antibacterial agent, particularly on E. coli, which were resistant to a lot of conventional antibiotics like the ampiclox and the augmentin. Then different volatile compounds, as listed, composed mainly of hydrocarbon, which is about 60%, ethanol, aldehyde, which may be linked to its unique antimicrobial property. I think it's with odor and other pharmaceutical functions. In conclusion, the study revealed that the plant bark tested possess a measure of antimicrobial potency against common microbial pathogen, which was resistant to some conventional antibiotics due to confirmed metabolite and phytochemical compound process, indicating that the plant is effective against various infections, including diarrhea, skin infection, mouth infection, and other gastrointestinal infection. Thank you very much for listening. Then in recommendation, further research can be done to isolate and determine the antimicrobial activity of those organic compounds from the bark of the plant against those isolate and other. It is also recommended that further research be conducted to test for synergetic effect of the plant bark. Thank you very much for listening.
Thank you. You have questions?
Question, I have one. Hello, sir.
We are waiting for you.
Okay. Yes, sir. I want to know if, all these conventional drugs, as you have said earlier, I want to know if the traditional ones, I don't know how to put it, can stay like the shelf life of the ones you are talking about. All these ampiclox and some other, they can stay for a long time. Their durability is what I'm talking about now. Like, how long can they stay intact?
Okay. What you are trying to say is that the conventional antibiotics,
Yes.
the conventional antibiotics are commercial, and we are talking about the augmentin they sell in the pharmaceutical store. We are talking about others, and all of them have self-life. The reason for their self-life is to determine the potency, the duration of potency of the microorganism against, of the antibiotics against the infection. Are you getting me now?
Yes, sir.
Now, not only that, not only the bioactive of the antibiotics. All those antibiotics, they have preservatives
Yes, yes.
that will keep them
Intact.
They have preservative. So the duration of the preservative always determine their safe life.
Thank you very much. Thank you.
Okay.
Professor Maria Conte, you can start. It's your turn to present.
Professor Gonta.
Da.
Okay, we are unable to get your PowerPoint. That's it.
Cum se deschide aici?
Okay, it can be viewed now. Thank you.
It's okay?
Yes, yes.
Tema mea este Catalytic and Photocatalytic Degradation of amoxicillin from aqueous solution by Fenton reagent and titanium dioxide. Amoxicillina este un antibiotic și pătrunde în apele naturale, din apele reziduale. Deci, obiectivul principal este de a înlătura, amoxicillin. Înlăturarea amoxicilinii din apele reziduale prin metode catalitice și fotocatalitice, utilizând reagentul Fenton și dioxidul de titan, metode fotocatalitice. Deci noi am studiat acest proces în funcție de diferiți parametri fizico-chimici. În funcție de pH, cum se schimbă CCO, în funcție de pH. pH 2 și 2, 3, 35, 45, 65. Deci cel mai mic CCO avem aici. Acesta este pH-ul 2 și 2. Deci în condiții acide are loc procesul de oxidare catalitică cu ionii de fier, reagentul Fenton. Pentru dioxid de titan s-a studiat procesul degradarea în funcție de pH. Avem concentrația amoxicilinii în miligrame pe litru. Deci la pH 5 este cea mai mică concentrație. Deci am optimizat pH-ul pentru reagent Fenton și pentru titanum O2. La fel, am studiat influența degradării asupra concentrației, influența catalizatorului. Deci am luat diferite concentrații de catalizator. Pentru reagent Fenton, deci cea mai mică, am calculat C supra lui C0. Și iată, acesta este pentru cel mai mic raport pentru această concentrație de reagent Fenton. Și pentru titan, la fel. Pentru titan am calculat constantele de viteză. Deci aici, cea mai mare constantă de viteză este pentru concentrația aceasta, 0,1 grame pe litru. Mai departe, am studiat degradarea în funcție de concentrația peroxidului de hidrogen, atât pentru reagentul Fenton, cât și pentru oxidul de titan. Deci observăm că dacă mărim concentrația peroxidului de hidrogen, 1 milimol și 3 milimol, deci mai bine merge procesul la 3 milimol. Iar pentru titan avem peroxid 1 milimol, 2 milimol, 3 milimol. Și astfel observăm că cea mai înaltă constantă de viteză, 0,0019, este pentru 3 milimoli. Însă noi nu putem să mărim concentrația peroxidului în continuare, deoarece se micșorează concentrația radicalelor OH. Deci pentru Fenton reagent, în prezență de peroxid, Fenton reagent, se formează radicalul hidroxil, care mai departe interacționează cu medicamentul amoxicilina și o oxidează. Deci s-a calculat constanta de viteză pentru diferite concentrații și diferit peroxid, 1 milimol, 3 milimol și iată aici sunt valorile constantelor de viteză. Și la fel a fost studiat în funcție de concentrația amoxicilinii. 100 de miligram pe litru, 200, 300. Deci gradul de mineralizare, oxidare-mineralizare, ajunge la 95%. Oxidarea-mineralizarea la 95% la condiții optime. Pentru titan, la fel se formează radicalul hidroxil, care este o particulă oxidativă și care mai departe poate interacționa cu substratul. Deci am studiat degradarea în funcție de timp pentru diferite concentrații și atât cu reagent Fenton, cât și cu dioxid de titan. Și dacă comparăm toate aceste date, toate aceste metode, gradul de mineralizare prin Fenton reagent, fotofenton, titano-2 UV și cu electrod titano-2 UV. Deci, cel mai înalt grad de mineralizare-oxidare avem Fenton UV. Deci, astfel, noi am studiat procesul de înlăturare a antibioticilor din apele reziduale. Așa, și a doua lucrare, Advanced Oxidation Process for Mineralization of Cationic Trimetilamonium bromid surfactant. Deci, scopul principal la fel este același, de a elabora metode de oxidare, mineralizare a surfactanțelor care pătrund în apele naturale. Iată, aceasta este structura surfactantului. Deci, principalul obiectiv este de a utiliza metoda Fenton, fotofenton și dioxidul de titan. A fost studiat acest proces în funcție de pH, de concentrația peroxidului, ionilor de fier, titan, lungimea de undă, concentrația surfactantului. Deci, surfactantul la fel se formează fenton reagent și fotofenton reagent, se formează radicalul hidroxil. Și aici, radicalul hidroxil. Radicalul hidroxil interacționează cu surfactantul. Și are loc mineralizarea. S-a optimizat în funcție de pH prin fenton și fotofenton. Fenton și fotofenton. Se observă că diferența nu este atât de mare. pH-ul optim 25. Concentrația în miligram pe litru la pH 25 este 9,2. Și la fel pentru cazul când avem în funcție de concentrația catalizatorului. S-au calculat vitezele pentru fenton și fotofenton, viteza 10 la 4 mol pe litru pe secundă, ele nu diferă, viteza crește până la o anumită concentrație de ion de fier. Mai departe, procesul nu crește, deoarece are loc hidroliza ferului bivalent. Se hidrolizează ferul. Așa, și mai departe, deci avem influența ionilor de fier în procesul UV, fenton, în funcție de concentrația ferului. Peroxidul, în funcție de concentrația peroxidului. Cel mai bine, concentrația în miligram pe litru la 1 milimol. 1 milimol. Deci cea mai mică concentrație. Mai departe, dacă concentrația crește, nu are loc procesul de mineralizare, deoarece se micșorează concentrația radicalului hidroxil. Și viteza, la fel, viteza crește până la 1 milimol. 1 milimol. Așa, deci mai departe avem viteza, cum variază viteza în funcție de lungimea de undă în procesul fotofenton, 254-365 nanometri. Deci nu este mare diferență în procesul fotofenton. Așa, și s-au calculat constantele de viteză și vitezele. Deci ele depind de concentrația concentrația surfactantului. În procesul de oxidare heterogenă cu titano 2 peroxid, am zis că se formează radicalii OH. Și s-a studiat la fel Pentru acest caz, deci s-a studiat în funcție de concentrația peroxidului, observăm că la 3 milimol este cea mai mică concentrație de surfactant. Și s-au calculat și vitezele. Așa, mai departe a fost studiat în funcție de concentrația catalizatorului. Deci cel mai bine viteza crește până la 2,5 și în funcție de păcaș. Cel mai optim păcaș este 4. Păcaș 4. Deci aici avem vitezele calculate și concentrațiile pentru diferite lungimi de undă. Și avem calculate constantele de viteză și vitezele. Constantele de viteză secunde minus 1. Deci cu cât este mai mare concentrația, cu atât este mai mică viteză, constantă de viteză. Și comparație avem fenton, fotofenton și titan. Pentru punctul acesta, observăm că la 20 de minute ele sunt toate aceleași. Concluziile am spus parcurs. Mulțumim, thank you. Mulțumesc. Dacă aveți întrebări, așa, cu asta noi am terminat sesiunea noastră. We finished.
Thank you for your presentation. You have questions? Professor, thank you.
Thank you.
Dr. Salihi Bolaji, you can start.
Okay. Thank you. Okay, good afternoon, everyone.
Yes.
My name is Sharafa SB. And I'm presenting on behalf of my group. Titled Trend Analysis of AOD and AE in Ilorin and Cape Verde, West Africa. This is the outline we hope to follow.
Dr. Bolaji, your internet is not...
Put it in slideshow.
Introduction.
Internet is not good. Let's wait a while.
Hello.
Hello. What
Dr.
happened?
Bolaji,
Okay.
you can start.
Sorry. Yes, there's a problem with the network, but I think. Okay.
It has started sharing. Okay.
Okay. So this is the
Yes.
Yes, you can see.
You can see the slide now.
This is the outline.
Yes.
We have an introduction. Okay. So we have the introduction, materials and method, results, discussion, conclusion as the outline. So the introduction, aerosols are just them are useful, but it's still a problem because anything that affects health has to be studied critically. So they affect climate too. Climate change. Aerosol, they scatter. Radiation, they are.
Oh, Dr. Bolaji, your internet is not good.
And they also contribute to so many other things like agriculture, nutrients. So types of aerosol, there's the natural ones that happens. Wow. Hello?
The network is not stable.
Yes, I can say that too. I think it has come on again. So I was there before it went off. So the natural aerosols are the ones that doesn't have any influence of man, while the anthropogenic comes about from the activities of man, burning bushes, raising dust, and the likes. So these are just the reactions it undergoes. The fine aerosols are the anthropogenic, the man-made ones, like flames and the likes, while the coarse one are the dust, sea dust, sand dust, and even volcanic eruption. But this is the most useful one to human being, because the more coarse aerosol in the atmosphere, the more rain you have in the atmosphere. But E-fine modes is much more than the coarse mode in the aerosol, rain in such environment. So the issues we have here is that aerosol loading in the atmosphere in West Africa due to dust, its transport, and biomass burning. So these are the issues we have. So we need to investigate it. So the aim of this paper is to investigate aerosols and their trends in Ilorin and Cape Verde using Moody's data. Ilorin and Cape Verde are the places
No audio.
Dr. Sarafa, we cannot hear you.
Doktor Bolaji, yes, sesi geliyor mu? Dr. Bolaji, I accept that I made a presentation. Dr. Bolaji? I accept that I made a presentation.
Hello.
Hello. Ah,
Yes.
we can't
What
hear
from
you.
literatures is that there's more loading. You can't hear me again?
Yes, we cannot. We are hearing you now, but before we can't hear you.
Okay. So I said what we know about Ilorin as a station is that there is more aerosol loading there, which doubles most of other places, and it varies from season to season. Rainy season has lower, while dry season has higher. Also, for the AE angstrom exponent, we know that AE shows the size distribution of aerosols. Just like I said earlier in the picture shown, the angstrom exponent, once the value is less than 1, it shows there is a predominance of dust particles, which are natural aerosol. And if the value is greater than 1, greater than or equal to 1, then we have a fine mode, which are biomass burning things. So the data used in this work is downloaded from a NASA website. It's called MAPS, Multi-Aerosol Product Sampling System. It's free. And the data, I only downloaded aerosol optical depth data and calculated the angstrom exponent, because for the wavelength I'm using, it's not supplied there. So these are the useful information. This one is a major aerosol equation. This is how I calculated my angstrom exponent. Then the data analysis. I did trend analysis, then seasonal fraction of the contribution of each types of aerosol. Then we have the coefficient of variation, which shows the spread of the size particles. So this is for the trend analysis. As you can see, this is AOD for Cape Verde. It shows a decreasing trend, a -9 exponential -5 for the period under consideration, which is 2002 to 2015. And similarly for e-learning, we did a trend analysis also, and we have an increasing trend, though not too significant, but it's something, because it shows that the atmosphere in e-learning is still getting increasingly polluted. So for the size distribution, the monthly cycle for the AE in Cape Verde shows an increment, meaning that there are more fine modes which are anthropogenic aerosols. So human activity is influencing the types of aerosol in this site increasingly. Similarly, for e-learning too, it is to have in Cape Verde. So these are some of the results. We have the mean value of the AOD in both stations is given here. We have the mean here. For AOD, we have 0.254, which is low. It's still polluted because for a less polluted or for a clear atmosphere, we need 0.06. But with this is 0.25. High. Then for e-learning, it is 0.687, which shows a very, very polluted atmosphere. But with the value of the average AE, we can see that this e-learning atmosphere is dominated by anthropogenic aerosols, which means e-learning people are really contributing to the pollution, not only the natural one. And here it's still natural, but more influence, because this is approaching 1, the value of 1 here. Then for the seasons, we can see here that the seasons shows that AOD in Cape Verde has 0.19, which is still polluted, but in the raining season, it is 0.29. We are expected to have a lower value in the rainy season, but this shows that a lot of things is happening, not only natural, but more anthropogenic aerosols are happening here. The size distribution also shows that there is increasing influence of because this is approaching 1, this is also approaching 1. The trend here shows an increasing trend of AOD during dry season, which is to be expected, and a decreasing trend in the rainy season, which is also to be expected because of the influence of rain. So for this, both the AE version, both them in that place with AOD in e-learning. During dry season, we have a 0.8, which is a serious issue. And during rainy season, 0.5. The difference is not much. So it's polluted both seasons. And the average for axial exponent is above 1, which means e-learning is dominated. This is just another confirmation. E-learning is dominated by anthropogenic aerosols. The trend also here shows that it is increasing. The aerosol loading during the dry season and rainy season are increasing, while the axial exponent during dry season increases, which means there are more influence of anthropogenic aerosols here. This one is decreasing, showing that there is a decreased influence of anthropogenic aerosols during the rainy season. Also, for the seasonal fraction, that is the contribution of each kinds of aerosol during each season. For dry season, AOD, the atmospheric turbidity in Cape Verde is contributed as a contribution of 31.39% during dry season, which is lower than what we have during rainy season. Rainy season is supposed to have more clear sky, but it means there is trouble with anthropogenic aerosol in this, which determines the size of the particles in the atmosphere. We can see during dry season, we have a contribution of 43, but during rainy season, we have 56, showing that there is still anthropogenic aerosol, which is even the most dangerous types of aerosol we can think of. In e-learning, we have the dry season contribution of the turbidity to be 58.81, which is to be expected because there is no rain to suppress dust. During rainy season, it is 41.19. The difference is also very small, not too large. And for the Armstrong experiment, which determines the size of the particles, we have 42.47 during dry season. And during rainy season, we have, meaning that the influence of anthropogenic aerosol is felt more during the rainy season. And we can understand that people burn bushes, if there's cold, they burn firewood and things like that. Then this plot here is just to show the distribution of the sizes. For optical depth, that is the loading in the atmosphere for Cape Verde, we can see that the thickness of the atmosphere varies from probably 0.1 to 0.6 here, having the peak around 0.22 here, which is manageable. Their frequency is written here. The highest is around 27%, the contribution. But for Ilorin, for AOD here, we have the value to be between 0.3 to around 1.8, which shows that Ilorin atmosphere is more polluted than that of this. And the maximum, the peak here is around 0.6, which has a contribution of around 28%, which is something that needs to be worked on. Then for the size distribution for Cape Verde, we have the distribution is between 0 to 1.6. 0, I said earlier, anything approaching 0 shows clearly dust. But if it approaches 1 and beyond, it means there are more fine molds, which will be biomass burning, bush burning, any other thing that is caused by man. So here, the kind of aerosol here is a mixed one.
Dr. Bolaji, your time is short.
Real, yeah, it's short, okay. Okay, so for Ilorin, the Armstrong exponent shows this trend to a lower range, but tilted towards the anthropogenic aerosol. So in conclusion, we have the trend analysis of the AOD shows that there is increasing aerosol in both stations, though there are variation between within seasons. Then for the trend analysis for Armstrong exponent, it only shows the increasing fine mold aerosol loading and increasing episode of fine mold aerosol during both seasons. The recommendation here is there is a need to increase the number of aerosol stations in West Africa. West Africa has 16 countries, but with 14 stations. And out of these, two countries, that's 5, meaning that we are left with only 11 for the, only 9 for the 11 countries that are remaining, which is not enough. We need more to track the changes here. Then future field campaign experiment should also provide insight into so many other processes and an approach to check the variation between day and night of aerosol needs to acknowledge those that provided the data for us for this work. And these are the references of what we consulted to arrive at this. Thank you for listening.
Thank you.
Please.
You have questions?
A question, please. I have a question. Can I go on?
Okay, go on, please.
Please, I want to know the medical effect of this aerosol, the effect of this erosion on human
On health.
health life. Can you hear me?
Okay.
Can you hear?
Yes, I can hear you. Thank you. Yes.
And the second question is, you and I think there's another presenter, Dr. Ibrahim Balogun, that presented a bit about this erosion. I can only see the quantity of aerosol in the environment. What is really, do you actually know the quality of the constituent of the aerosol? Hello. Can you hear me?
I can't get the second.
The second question, I'm asking about the constituent of the aerosol in the environment. Can you hear me? Hello, Doctor.
Dr. Boliju, I cannot hear you.
Hello, yeah.
Okay,
yeah,
you're back.
Dr. Sarafa.
Yes.
He is trying to ask whether you carry out the mineralogy of the study area.
Yes.
No. We did not carry out the mineralogy. We did not carry out the, but this is just a part of.
Excuse me. For knowledge sake, can we? Do you have the idea?
Yes. This is a small part of a big project. It is characterization of aerosol in sub-Saharan Africa. So the data we use, the preliminary data, are not data generated by us. They are data generated by NESA. We use it for this analysis. But after this now, we'll go to the field and get those dust ourselves, then go to lab and analyze and get what it contains. But from literature, we know people have seen nitrates. They have seen nitrates majorly in the mineralogy that they've carried out. But for the health issue, the aerosols have been linked to the how do I put it? Prevalence of what is this thing called? Lungs issue.
Okay.
Lungs
cancer.
Not lung cancer. Lungs issue, not cancer, really.
Lung.
Meningitis, yes, and meningitis. And meningitis too, yes.
Okay, thank you.
Linked to that.
Thank you.
So have I answered your question? Okay.
Yes. I'm satisfied. Thank you.
Thank you for the presentation. Your certificates will be sent this evening. See you. Have a nice day. Session is over.
Okay, thank you.